Hello everyone and welcome back to Budi Network Academy. I am Budi and welcome to the first technical episode of our intermediate networking chapter. In our previous chapter, we learned the fundamentals of networking including switches, routers, IP addresses, MAC addresses and the OSI model. Now it's time to take the next step. In today's video, we are going to learn about VLANs or virtual local area networks. We will understand what a VLAN is, why we use VLANs, and how VLANs help us organize and manage modem networks. So let's get started. Let's imagine a company with several departments. We have the IT department, the HR department, and the management department. All of these computers are connected to the same physical network. But do we really want every device to be part of the same network? Not necessarily. We may want to separate these departments for better organization, security, and network management. This is where VLANs become useful. VLANs allow us to logically separate devices into different networks, even when they are connected to the same physical switching infrastructure. So, what exactly is a VLAN? VLAN stands for Virtual Local Area Network. A VLAN is a logical network created within a physical network. Instead of putting all devices into one large network, we can divide them into different logical networks. For example, we could create VLAN 10 for IT, VLAN 20 for HR, and VLAN 30 for management. The important thing to understand is that VLANs allow us to separate network traffic logically without necessarily needing a separate physical switch for every department. Let's look at a simple example. Here we have one physical switch, but inside this switch we can create multiple VLANs. VLAN 10 could be used by the IT department. VLAN 20 could be used by HR, and VLAN 30 could be used by management. So, even though these devices may be connected to the same physical switch, they are logically separated into different VLANs. This is one of the main advantages of VLANs. We can use the same physical network infrastructure while creating separate logical networks. One of the most important concepts to understand about VLANs is the broadcast domain. In a traditional network without VLAN segmentation, many devices may belong to the same broadcast domain. When we create VLANs, each VLAN becomes a separate broadcast domain. For example, VLAN 10 has its own broadcast domain. VLAN 20 has another broadcast domain, and VLAN 30 has another one. This helps reduce unnecessary broadcast traffic and makes the network easier to organize. So remember, one VLAN equals one broadcast domain. How do we identify different VLANs? We use something called a VLAN ID. A VLAN ID is a number used to identify a VLAN. For example, VLAN 10 IT, VLAN 20 HR, VLAN 30 management. These numbers help the network switch determine which VLAN a device or a frame belongs to. In real networks, network engineers can create and assign many different VLANs depending on the organization's requirements. So, why do network engineers use VLANs? There are several important benefits. First, network segmentation. VLANs allow us to separate different groups of devices. Second, better organization. We can organize users and devices according to departments or functions. Third, reduced broadcast traffic. Each VLAN has its own broadcast domain. Fourth, improved security. VLANs can help separate sensitive devices and users from other parts of the network. And finally, easier network management. So VLANs are not just about dividing a network. They help us build networks and are more organized, manageable, and scalable. Let's look at a real-world example. Imagine an office with 3 departments: IT, HR, and management. Instead of creating a completely separate physical network for each department, we can use VLANs. IT devices can be assigned to VLAN 10. HR devices can be assigned to VLAN 20. And management devices can be assigned to VLAN 30. All of these devices can use the same physical switching infrastructure. This makes the network much easier to manage as the company grows. And if we add a new employee to the IT department, we can simply assign their switch port to the appropriate VLAN. Now here's an important question. Can devices in different VLANs communicate directly with each other? The answer is no, not at layer 2. For example, a device in VLAN 10 cannot directly communicate with a device in VLAN 20 through normal layer 2 switching. To communicate between different VLANs, we need layer 3 routing. This can be provided by a router or a layer 3 switch. This process is called inter-VLAN routing. And this is going to be an important topic in one of our upcoming episodes. So remember, different VLANs require layer 3 routing to communicate with each other. Let's quickly review what we have learned today. VLAN stands for Virtual Local Area Network. A VLAN is a logical network created within a physical network. VLANs allow us to separate devices and network traffic logically. We also learned that each VLAN represents a separate broadcast domain. VLANs are identified using VLAN IDs. We can use VLANs to improve network segmentation, organization, security, and management. And finally, devices in different VLANs need layer 3 routing to communicate. These are some of the most important concepts to understand before we move into VLAN configuration and routing. Thank you for watching this video. I hope you now have a clear understanding of what a VLAN is and why VLANs are so important in modern networks. If you found this video helpful, please like, comment, and subscribe to support Budi Network Academy. And here's today's question. Why would a company use VLANs instead of putting all of its devices into one network? Share your answer in the comments below. Until next time, learn, troubleshoot, connect. I am Budi, and I will see you in the next video.